Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about adding and subtracting with radical expressions and rational exponents. So if you're combining radical expressions, you want to only combine radicals that have the same radicand and the same index. And then if you're combining rational expressions, you want to only combine rational exponents with the same base and the same exponent. Okay, so perform the following operations and write your answer in radical form. Okay, so that means our answer should have a square root, cube root, fourth root, or just be an integer if we can get it to there. All right, so 2 times 8 to the 1/2. Well, I know anything to the 1/2 power is really the square root of that number, plus 7 times 8 to the 1/2. So I can rewrite this, or I can just combine them. So I could change them to radicals right away, or I can combine them since they have the same base and the same index, or the same base, the same exponent and index. Then I can just add the 2 and the 7, and that gives me 9 times 8 to the 1/2. Okay, and then to get it in radical form, I would change the 8 to the 1/2 to the square root of 8. So I have 9 times the square root of 8. All right, this one, I have the cube root of 10 plus 6 times the cube root of 10. So they have the same base, they have the same index, and I can go ahead and add them. There's a 1 in front of the cube root of 10. So I can do 1 plus 6. That would give me 7 cube roots of 10. Okay, so I have the cube root of 54 minus the cube root of 2. Well, I do not have the same radicand, that number that's inside of the radical symbol. So I need to get it so that I have a cube root of 2, or both of them be a cube root of 54. But since I can't make the 2 become a 54, I'm going to try to make the 54 become a 2. So if I take 54 and I divide by 2, I get 27 times 2. So I'm going to break 54 up into 27 times 2. So it'll be the cube root of 27 times 2 minus the cube root of 2. I just brought down the right side. Now I'm going to break up everything on the left, so I'm going to break it into 2 pieces. So I'm going to have the cube root of 27 times the cube root of 2 minus the cube root of 2. Now the cube root of 27 is actually a perfect cube. Okay, so 3 times 3 is 9, and 9 times 3 is 27. So the cube root of 27 is 3. So I have 3 times the cube root of 2 minus the cube root of 2. Now there's really a 1 in front of that second cube root of 2. And so when I subtract them, I get 2 cube roots of 2. All right, I have the square root of 50 plus the square root of 10 minus the square root of 18. Again, these don't have the same radicand, the number inside of that radical symbol. So I want to try to get it so that they have something in common. Okay, so I could break up 50 into 25 times 2. And I could break up 10, I could do it into 5 times 2. And that's not really going to help me. So, and then 18, I could break it up into 9 times 2. Okay, so I'm looking for perfect squares. So 25 is a perfect square, 9 is a perfect square. There isn't a perfect square that multiplies by something to make 10. So I'm just going to leave it as the square root of 10. All right, so then I'm going to break it all up into individual pieces. So I have the square root of 25 times the square root of 2 plus the square root of 10 minus the square root of 9 times the square root of 2. Well, the square root of 25 is 5, and the square root of 9 is 3. So I have 5 square root of 2 plus square root of 10 minus 3 square root of 2. Now I have some like terms. I have 2 pieces that both have square roots of 2, so I can combine those 2. I can't do anything with that square root of 10. So I'm going to have 5 minus 3 is 2 square roots of 2 plus 10. And that's it. That's as far as I can go. All right, perform the following operations and write your answer in radical form. So now it's with rational exponents. I have 2 to the 1/3 plus 8 to the 1/3 plus 54 to the 1/3. Okay, 2 to the 1/3 plus 2, okay, 2 times 2 is 4 times 2 is 8. So 8 to the 1/3 is really just 2, because that's the cube root of 8. And then 54 to the 1/3, I can break 54 up into 27 times 2, because I need to have the same base. Okay, that base is the number being raised to the power, so I need 2. So again, I need that 54 to become a 2 somehow. So I'm going to break it into 27 times 2, and I know that the 27 is a perfect cube. 3 times 3 is 9, times 3 is 27. So when I break each piece up individually, I have 2 to the 1/3 plus 2 plus 27 to the 1/3 times 2 to the 1/3. 27 to the 1/3, we just said is 3, because 3 times 3 times 3 is 27. And when you're raising it to the 1/3, that means you're taking the cube root. Okay, so 2 to the 1/3 plus 2 plus 3 times 2 to the 1/3. So now I can combine my 2 to the 1/3 pieces. Well, I have 1 2 to the 1/3, and then I have 3. So then I have 4 2 to the 1/3 plus 2. Okay, and now if I want to write it back in radical form, I would write 2 to the 1/3 as the cube root of 2. So I have 4 cube roots of 2 plus 2. All right, this one, I have 12 cube root of 2z to the 5th minus z cube root of 54z squared. So again, that 54 keeps coming up. So these numbers that break up into perfect cubes, you'll probably keep seeing. Okay, so the 54 I can break up into the cube root of 27 and the cube root of 2. That way I have the same base, that 2, but then I also need the z to the 5th power and z to the 2nd power. I need to work on that somehow. Okay, so if I take the cube root, I have the z in front, and then I could take the cube root of z squared. So I just broke it up into all its pieces. And then I'm going to, on the other side, I'm taking the cube root of z to the 5th. So I have 5 z's, and I'm taking the cube root. So I'm going to take 3 of them and pull them out, and that's going to leave me with 2 z's inside of the radical. So I'm going to have 12. I pulled out 1 z. I have the cube root of 2 times the cube root of z to the 3rd power times the cube root of z squared. So I just broke up z to the 5th as z to the 3rd and z to the 2nd. Okay, and if I take the cube root of z to the 3rd, that becomes 1z that I can pull out front. Okay, so I have 12z, and then I have the cube root of 2z squared minus 3z and the cube root of 2z squared. So that my base, my index, my radicand, everything is matching. So I can go ahead and just do 12z minus 3z. That would give me 9z, and then times the cube root of 2z squared. Which of the following expressions are equivalent to 3 square roots of 2? Select all that apply. Select all that apply means I need to have at least 2 answers. So I have 3 to the 1/2 power plus 2 to the 1/2 power. Anything to the 1/2 power means it's going to be the square root of that base. So the square root of 3 is not a perfect square, and the square root of 2 is not a perfect square. And if I combine them, I'm not going to get 3 square roots of 2. So let's look at the next one. I have 8 to the 1/2 plus 2 to the 1/2. So I really have the square root of 8 plus the square root of 2. Well, the square root of 8, I can break that up so that I have the same radicand, and then I can combine them. So I could break that up into 4 times 2 to get 8. So that'd be the square root of 4, which is 2, and then the square root of 2. So I have 2 square root of 2 plus the square root of 2. If I have 2 square roots of 2 plus another square root of 2, that gives me 3 square roots of 2. So that one is equivalent. All right, the next one, I have 3 times 2 to the 1/2. Well, 2 to the 1/2 can be written as the square root of 2. So this becomes 3 times the square root of 2. So that one is also equivalent. All right, the square root of 18, I'm going to try to break that up. All right, so 18, I could break that into 9 times 2 to get 18. 9's a perfect square. And so when I take the square root of 9, I get 3. So I have 3, and then the square root of 2 I can't do anything with, so it's 3 square roots of 2, and that is equivalent. All right, the next one, I have 2 times the square root of 18. Well, if I just did square root of 18, and that gave me 3 square roots of 2, If I multiplied that whole thing times 2, that would give me 6 square roots of 2. So I know that one's not going to work. And then the last one, I have the square root of 8 plus the square root of 2. And if I look at the second one, when I simplified it, I had square root of 8 plus the square root of 2. And that continued to work out. So that I know is going to work. All right, find the perimeter of the following figure. So I need to get these so that I can combine them. So the smallest radicand that I have is square root of 5. So I probably want to break them up so that they all somehow have a square root of 5. So I'm going to start with 3 square roots of 20. Okay, well, I know 5 goes into 24 times, and 4 is a perfect square. So I'm going to go ahead with that. And I'm going to break that into the square root of 4 times 5. So I'm going to have 3 times the square root of 4 times the square root of 5. Well, when I do the square root of 4, I get 2, because 2 times 2 makes 4. So I have 3 times 2 times the square root of 5, which gives me 6 square roots of 5. Now if I look at 3 square root of 125, well, 5 goes into 125 25 times, and 25 is a perfect square, so I'm going to go with that. And I'm going to break that up. I'm going to have 3 times the square root of 25 times the square root of 5. So the square root of 25 becomes 5, so I have 3 times 5 times the square root of 5. And 3 times 5 is 15, so I have 15 root 5. And then next one I have 4 times the square root of 80 plus the square root of 5. So I'm going to break up that square root of 80, and I get 16 times 5 makes 80. So I have 4 times the square root of 16 times the square root of 5 plus the square root of 5. The square root of 16 is 4, so I have 4 times 4 times the square root of 5 plus the square root of 5. And 4 times 4 is 16 square roots of 5 plus square root of 5. So that gives me 17 square roots of 5. Now, if I'm finding the perimeter, that means to add up all the outside edges. So I'm going to add 17 square root of 5 plus 6 square root of 5 plus 15 square root of 5. And that's going to give me 38 square roots of 5. And if they gave me measurements like feet, inches, yards, I would be sure to include those. All right, that's it.